Hey guys, uh, myself Prashant Bardwaj, and I have Matthew with me, my colleague from Intel. And today we are excited to talk about advancing AI with OpenVINO. All right, so the first thing I want to talk about, why AI on the edge? There are 5 reasons. Number 1, privacy, so you can keep your data local to you as part of your enterprise. Responsiveness, because now data is close to you, so you can get better user experience. And then finally, with your local data, you can personalize your experience, which is customized to your own use cases. It also allows you to enable these use cases when you have limited or offline connectivity. And lastly, cost. As you guys know, with generative AI, the cost of deploying this model is quite prohibitive, especially on cloud. And with AI PC and Edge, we can allow all of these models to be deployed in a cost-efficient manner, which will help you to deploy them at scale. Couple of points about how Edge and AI PC will be helped by AI and vice versa. As you see today, we are in the age of the AI co-pilots, right? Where these co-pilots can augment humans and help them achieve tasks. You know, from coding assistants to personalized search, the use cases are many. As you go forward in the next generation of these AI agents, they become your personalized agents. So imagine a personalized agent for you on your PC, which is customized for you, built for you, and helping you achieving your daily tasks. So that is the second phase of the AI agents. As you keep going forward, we are going to be in the world of agentic AI. And these are autonomous agents which can adapt, react, and act on your behalf. So you can imagine new use cases where you can tell the agent to do some task. It will use a fixed amount of compute to be able to do tasks and come back to you with the answer. And that you can imagine so many of these use cases in the world of enterprise, healthcare, finance, and many more. So the sky is the limit in that case. I also want to mention the vast ISV ecosystem we have. I think this was covered in previous sessions. But what I want to say to you that we have more than 200 ISVs in the AI ecosystem with 400 plus features enabled today. And it goes all the way from productivity, collaboration, security, manageability, and creative apps, where customers are able to deploy not only the classical AI, which is computer vision and NLP, but now with generative AI, able to unlock new use cases. So for example, in productivity space, we have use cases like transcription, meeting summaries, background blur segmentation, which are used by multiple customers in that space. For creator workflows, we have a set of use cases which allow creators to improve their productivity by using video editing tools and things of that sort to enable them to unlock new use cases. And there are many more use cases coming down the line based on RAG, based on the agentic AI down the line. So this is where I wanted to share with you our approach to AI software stack. And there are 3 principles which are driving this. 1, how do we maximize user experience and customer value? 2nd, how do we make it easy for developers and customers to deploy AI at scale? And number 3, meet developers where they are. And this is where our OpenVINO AI stacks comes in. For customers, it's about seamless experience, 0-day model deployment, and out-of-box experience. For developers, it's about tools, frameworks, and solutions that enable them to deploy these things at scale. And we have a vast, substantial support for our ecosystem as well, where we can deliver things to developers where they are. For example, integrations with PyTorch, Hugging Face, LightRT, WebNN, Onyx RT to support the vast majority of the ecosystem so that we can help developers where they are in terms of deploying these models at scale. And I think with that, I would like to invite Matthew on the stage to, to talk about the greatest and the latest we have to offer on OpenVINO today. Go ahead.
Thanks, Prashant. Appreciate it. All right, so let's talk about OpenVINO. I run technical marketing for OpenVINO at Intel. OpenVINO, some of you are familiar with it, using it, love it already. Some of you I've found talking this week, it's brand new. You've never heard of it. OpenVINO is an open source project that Intel drives, github.com/OpenVINO toolkit, and it's an inferencing optimization library. There are several in the industry that do this. The tools you use for training a model are not the best for inferencing a model, especially on AI PC or the edge. And so the vast majority of ISVs on AI PC and the edge on Intel hardware use OpenVINO. The way it works is you take a standard model that you've trained in PyTorch or some other framework, and then you run it through the OpenVINO optimization layer. It processes and quantizes and compresses that model in different ways. And then you use the OpenVINO runtime in your application or solution to actually then take that compressed model and run it in the most optimal way possible on a system that often has far less memory, far less storage, far less compute than the cloud. As powerful as AI PCs are, they're still not Xeons, they're still not big iron in the cloud. And so you have to, if you use a library like this, you can get fantastic performance that delivers a great user experience to users. And today, OpenVINO supports the vast majority of silicon at Intel, Atom all the way up to Xeon, with a special focus on AI PC. We support our discrete GPUs as well in the Arc family. Core Ultra for sure. And so the predominance of OpenVINO usage is in AI PC and Edge, but we support Xeon and the data center as well. I talked a little bit about some of the features and advantages of OpenVINO. It really is about getting that smallest model in binary size, optimization down, really compressing things. The deployment package for OpenVINO is less than a couple hundred megabytes. It can run efficient inferencing in 4 gigs of RAM. It actually, if you wanted, you can run it on a Raspberry Pi. We have a very minor ARM CPU plug-in in there as well, just to see if it works, and it'll work on really low-end hardware. But of course, its sweet spot is co-optimization with Intel Silicon, where in the final stages, especially the final year before an Intel processor comes out, we have the software team co-optimize with the silicon team to get greatest performance at launch and beyond. And OpenVINO is the way to take advantage of the NPU on Intel Core processors, and has plugins for each of the major IPs on the SoC. So it has a GPU plugin, which handles discrete and integrated GPU. It has an NPU plugin, and it has a CPU plugin. We recently launched an OpenVINO Model Hub, where you can get the latest performance of OpenVINO against major LLMs and computer vision multimodal models on a wide range of Intel hardware. If you go to openvino.ai and click Models, you'll get to our Model Hub, and there you can click into a wide range of silicon across several generations of Intel processors. You can pick which model you care about, and you can see throughput and latency for those models to help you calibrate whether a given model will run effectively on a certain piece of silicon. Of course, there's no substitute for running the model yourself in your own solution, in your own application. But it's a good ballpark way to start to hone in on, can this processor run this workload at this performance? One of the questions we get a lot is whether to use OpenVINO's native APIs directly or go through a third-party ecosystem integration. And both are good options for different reasons. If you go down the native API flow, you're going to get a bunch of knobs and switches that you don't otherwise get, and that will allow you to take maximum advantage of all the performance Intel processors provide. And so one feature we have, for example, is an auto balancing API that allows you to tune where the model's inferencing happens dynamically at runtime. OpenVINO has heuristics in it. It can, based on how much memory you have, the size of the model, the generation of processor, it can automatically route the AI to the available compute on the system if you wanted to. Or you can go all the way to the other side of the coin and you can hyper tune where you want that inferencing to run. You can say run only on E cores or only on P cores. If you're running on a Xeon, you can say only run on X number out of the total cores in the system. You can say only run on 2 of the 3 discrete accelerators that are attached to the system. You have all of this flexibility on how you tune and run. It can even do things like auto batching, where if you want maximum throughput, it will dynamically calibrate the batch size to generate the best throughput on that system in a tuning fashion that is far more granular than human engineers would optimize for. And so there's a lot of power there that using an industry standard API that's less Intel aware wouldn't give you those knobs and switches. Similarly, we have an OpenVINO model server for inference serving. We use it uses standard open AI endpoints or TensorFlow serving, PyTorch serving APIs are supported, but it takes all advantage of OpenVINO on the back end. And so it is the most performant, efficient way to do model serving on Intel hardware. And then we'll talk about our new Gen AI API in a few minutes. Alternatively, especially if you're trying to support a lot of different platforms, or if you're in the early stages of discovery on Intel, or if your application already leverages industry open APIs, then you might want to use one of these integrations. And we have a large set and ongoing new ones onboarding all the time of APIs where we've integrated OpenVINO into the back end. So that if you're using that API and you flip the right flag, you'll actually get OpenVINO being leveraged underneath the hood. So whether you're using Onyx runtime and you're using the OpenVINO execution provider, or whether you're turning on the OpenVINO device in VLLM or any one of our other integrations, you can get most of the benefits of OpenVINO through one of those APIs. We're rolling out more all the time, as I mentioned. We actually are just in the process of rolling out Executorch, and we have more that we have planned over the coming months. Now, the advantage of that is, the same code would theoretically run on another vendor's hardware. The downside is you're not going to get all the knobs and switches, and therefore not quite the maximum performance that you'd get on an Intel processor. For example, Triton inferencing serving from NVIDIA actually has an OpenVINO path plugin for it. So if you're already using Triton, you can use their OpenVINO integration to take advantage of OpenVINO. The issue is that their version only enables Intel CPUs, not Intel GPUs. So you're not going to actually take advantage of all Intel hardware going down a Triton server path because they want you to use their GPUs. So again, those paths work, often with some drawbacks that you'll want to understand as you're making your own decisions. And then just one of our most recent features that we've really been spending a lot of energy building out has been our new Gen AI API with OpenVINO. And this is similar to what you would get if you used Hugging Face Optimum, for example. By the way, we totally support Hugging Face Optimum. So if you use Optimum Intel and turn on OpenVINO as the back end, again, it'll work great. But if you want something even more performant with less code, take a look at our new Gen AI API. And in this API, we are integrating in the latest cutting edge research on getting great AI performance, especially in low memory situations, like a 16 or 32 gigabyte memory AI PC. So just some of the things that we are working on, things like KV cache optimization. So this is how tokens are stored in memory, and you don't want to flush that cache every time you make a new call out in your LLM, or you're going to be really slow. It's actually a memory-bound process, not a compute-bound issue. So keeping more of that in memory and having very intelligent memory management is key. If I pick another one on this list, speculative decoding. That's a more modern technique where you can take a lower parameter lower billions of parameter version of a model, say a 7 billion parameter version, and have it be the pace runner model running simultaneously with a slower version, say a 13 or 70 billion parameter version that's more accurate. And as long as the fast version at the end of a chunk of context is giving you the same result as the slow one, you'll just keep accepting the slow one's, the fast one's results. So you actually are running at the speed of the fast one with the accuracy of the slow one, and you only fall back to the slow one when their results differ. And so setting that up to run is fairly tricky, but it's actually quite easy with the GenAI API. And so these are just some of the many techniques that we're building in, and we're continuing to advance this API. And so if you're looking to do inferencing, if you have an inferencing focused solution, edge to cloud with a special focus on AI PC and edge, then OpenVINO, either through the native APIs or through one of our many integrations, is probably what you're looking for. And just to wrap up, a lot of use cases are blooming in the AI PC, as Prashant talked about. This is an exciting area. It's still pretty new for all of us, new to AI PC, but there's a lot of applications that Intel's already enabled. So we're getting some mileage under our belts here for making this work really well, and so these recommendations are starting to rise to the surface for all of you to take advantage of. We support a wide variety of industry ecosystem APIs for developers. We support whatever developers want to use. We do recommend OpenVINO. That's what's co-optimized with our silicon, and we have a lot of great APIs in OpenVINO to help with your AI development. So with that, that's the last slide. Let's see how we're doing on time. We came in efficiently, so we probably have the time now to take a few questions if people have any. I don't know if we have a roving mic or not. Do we have a roving mic?
Questions?
Yeah, we have time maybe for a few questions?
Yeah,
Okay.
of course. Raise your hand. Yeah. There you go.
Hey, Matthew, regarding that new feature that you explained, the parallel execution of the simpler and more complex model, give us some more detail. How is this run? They're running both on the same structure, they're running in parallel on the same machine.
Yeah.
They allocated some part of the machine to one, some part for the other.
Exactly.
What's the
So you
details?
take like Llama 3, right? You could take Llama 3.7, Llama 370. You want the performance of 7, but the accuracy of 70. If you use speculative decoding, it basically will decode using the 7 billion parameter model, and then every now and then true up with the 70 billion version periodically. And as long as the answer is the same, it's like, good, the 7 billion got it right. We're good to go. And so then we'll just keep going with the 7 billion. And then we'll periodically check in. I'm not the architect who built it, but it is basically periodically running both models. But you're getting most of the speed of the fast model, and as long as it doesn't differ that much, you never have to end up using the slow model. But occasionally, if it does, if you're off by just a few tokens, then it'll pull that from the slow, accurate model, and then keep going with the fast model again. And again, if you were to hand roll code to do this, it'd be fairly tricky. So we did it once for everybody.
Okay, nice. Thanks.
Do you have another question? Yep, coming to you in the back.
Simple question. Is there any cost to use OpenVINO? Is there any license that goes along with it?
It's an Apache 2 license. It's totally open source on GitHub. Knock yourself out, it's free.
Amazing. Another question? Don't be shy if anybody else.
And it's not new from Intel. We've had it since 2018. It's used by hundreds of thousands of developers around the world. It started really focused on the edge and computer vision. We added Gen AI a couple of years ago, and now it's become the main thing on AI PC as well.
Any final questions for these gentlemen? All right. Well, I have a feeling that they'll hang around up here for a moment. If you're a little mic shy and don't want to say it in front of everyone, they'll be here and you can ask them in person. So let's give them a big round of applause for their amazing presentation. Thank you both so much.